So, schedule.
Why does that always happen?
Schedule change. The schedule says that we have notes today, lab tomorrow, work day Thursday, test Friday and Monday. I'm changing that to notes today, lab tomorrow, work day Thursday, work day Friday, multiple choice at home on Monday for everybody, and then free response in class on Tuesday.
How, say we get quarantine or the people in quarantine, how will we do the lab?
It's a virtual lab.
Okay.
They're still virtual.
Cool.
And that's kind of part of the reason that I'm keeping labs virtual for now, is it's too much to make stuff up. So
Right.
everything at this point can be done at home except for the free response test. And you'll just make that up when you get back.
So it's not one of those labs where you have to Google Meet in here? 'Cause
Nope.
that was really difficult.
We're not doing that anymore either because it's
Cool.
just
Yeah, I don't know how I did that lab. I just kind of
okay.
did it.
Let's start out with questions over homework. Anything you want me to go over homework wise? Problems? Questions? Homework is due a week from today. Okay, let's talk about. Oh, yep. Go ahead.
I had a couple number 6 on the it was stepping you through the correct lab procedure. I understand the safety thing. Are we just for the safety just supposed to say that you put the
Add acid to water.
acid to water?
Yep.
Not the other way around.
That's it.
Okay.
Like I've added.
Anything else?
Good.
Okay, yesterday you were supposed to watch a video over chromatography and distillation. Chromatography, I don't want you to get too hung up on chromatography. All you need to know is that you make your chromatograph, which is the paper. You put a line, made a pencil on it. And then usually chromatography, you use ink from different markers. You could use like dye from foods. But what you're trying to do is find what that's made of. So black markers, not Sharpies, but other types of black markers, are made of different ink colors mixed together. So if you have a black marker and you draw with it, it probably is red, green, blue, purple, maybe inks all mixed to make the black marker. If you put a dot of black marker on a piece of paper like this is called your stationary phase, and you dip it in water below your line, this is like a coffee filter. And the water will travel up the paper. And as it travels up the paper, it will grab this ink. And as the ink travels up the paper, the less polar parts of the ink want to stay on the paper because the paper is non-polar. The more polar parts of the ink dissolve in the water easily because polar like dissolves like, and it travels farther up the paper in what we call the mobile phase. And what you wind up with are streaks of color. And you might wind up with blue part of the ink up here and a red part of the ink down here and a green down here that's really non-polar that you can barely see. But you just get like this streak as the black travels up the paper. And then it goes all the way up until it doesn't go anymore. And you pull the paper out, and then you can measure the RF values for each color. And that tells you something about how polar those colors are. So the first thing you measure is how far your water traveled. We'll call that X. And then you measure how far each color traveled. Y, Z, Q, whatever. And then you can measure RF. So for blue, it would be Y over X. The distance blue traveled divided by the distance the water traveled. The bigger the RF value, the more polar the color. And what we really use this for is we make chromatograms for all kinds of ink. And then if you find an unknown ink or an unknown dye, you can make a chromatogram for that and match it to a known one. This is used a lot in forensics. It's more complicated than what you need to know. Just know how to measure RF values and compare chromatograms on the AP test. Just know what this means if you see it, basically. Questions about chromatography? On Thursday, I'm going to do an example and show you what it looks like. That's it. Okay, the other thing that you were supposed to learn about yesterday was distillation. And distillation is separation by boiling point. So if you have a mixture of liquids, solutions, so maybe different types of alcohols mixed with water, you could distill it to separate them, because one of them will have a lower boiling point than the others, and it will boil off first, and then you would have others and you could boil them off according to boiling point. This is a very common practice in making moonshine. So during Prohibition, alcohol was completely illegal. No matter how old you were in the United States, you could not consume or purchase or make alcohol. But moonshiners did anyway, because people find ways around the law. And when you make moonshine, you have a water is present. Then you have the ethanol, which is the moonshine, and other alcohols. Methanol is one of them. And the moonshiners have to boil off the methanol first, distill it, to get rid of the methanol. Methanol cannot be consumed. If you drink too much of it, if you consume too much of it, it can cause blindness. And it happened a lot in Prohibition because they were not making moonshine very well. It was not regulated at all. It was being made in back areas and whatever. So you distill it. So you have your container of your moonshine, all the mixture, methanol, ethanol, water, other junk, and you put it on a fire, hot plate, whatever, and you boil it. And you reach the boiling point of methanol. It's the lowest because methanol is the smallest and has the weakest intermolecular forces. And the methanol boils off and you just let it escape. You just let it go. You don't want it. Then it stops boiling when all the methanol is gone until you reach the boiling point of the ethanol. And then once you get there, it starts to boil again and you start getting the ethanol coming off. And in distillation, you want to trap that product so it gets trapped in a new container. That's the moonshine. That's the part that they wanted to drink. This is distillation. We use distillation in organic chemistry most of the time because you make different alcohols in organic chemistry and you need to separate them from the water. So you distill it by boiling the alcohol off and catching it in a different container. Questions about that? No? All right, something new today, Beer's Law.
Go from ethanol to beer.
This is the Beer-Lambert Law. And what Beer's Law says is that the absorbance of a sample, A, is equal to this. And we're going to talk about what this means in just a second. A is absorbance. This is the molar absorptivity. It's a constant. B is the path length. And C is the concentration. Beer's law to find the concentration of colored solutions. And they have to be colored, and you'll see why in just a second. Okay, so think about making Kool-Aid. If you make grape Kool-Aid, you start with your pitcher of water. You put in 1 spoonful of Kool-Aid powder. You stir it. It's a very light purple color. Almost colorless, but very light purple. It has a low concentration, so it's a very light color. You decide that you want your Kool-Aid to be very grapey, and you dump the whole thing of grape Kool-Aid in your water, and you stir it up. Now it's dark and murky, right? Your concentration is very high. Okay, so just keep that picture in your head. Light color, low concentration, dark color, high concentration. Okay? Then, this is something you need to know about light. If you've had physics, this is review for you. White light is all of the colors of light mixed together. This is why if you shine sunlight through a prism, you see a rainbow. Because white light is red, orange, yellow, green, blue, and violet, all mixed together in equal amounts. If you're wearing a red shirt, the white light hits your red shirt, the red is reflected back to the person's eyes, and everything else is absorbed. Orange, yellow, green, blue, violet. That is reflection and absorption. In this case, we're going to talk about transmittance and absorbance, but it's the same idea. That's why these solutions have to be colored. So, let's say you take a sample, and it's copper nitrate. Copper nitrate is blue, and you put it in something called a cuvette. A cuvette is a little rectangular prism container. And you want to find the concentration of your sample. Now, you can tell if it's very concentrated or not very concentrated based on how dark it is. The darker the blue, the higher the concentration. The lighter the blue, the lower the concentration. But using this method, we can find the exact concentration based on the absorbance. So what happens is you take light and you shoot it at your sample in something called a spectrophotometer. And you want maximum absorbance. The way that we get maximum absorbance is by using the opposite color of light. They'll give you a color wheel. You don't have to memorize this. But you just need to know if your solution is blue, on the color wheel, opposite of blue is really orange, but I don't have an orange marker, so I'm using red. Orange, red is fine. So you shoot red light at your blue sample. The higher the concentration is, the more light will be absorbed. Does that make sense? The lighter your sample is, more light will be transmitted. It will go through. Transmittance and absorbance are supplements. They add up to be 100. So if the transmittance is 50%, the absorbance is 50%. If the transmittance is 90%, the absorbance is 10%. It's how much light goes through and how much light gets absorbed. The darker the sample, the higher the concentration. The higher the concentration, the higher the absorbance. Do all those make sense in your head? absorbance, concentration, color. Darker color, higher concentration. Okay, so you shoot the light through, some of it goes through. There's a detector here that reads the amount of transmittance and turns that into an absorbance value. It spits out an absorbance. Okay? Then you can graph this. You can make a graph of absorbance versus concentration. Okay, so in the lab, you would make some known concentration solutions. You would make maybe 4 solutions with a concentration of 0.1, 0.2, 0.3, and 0.4 molar. You would know their concentrations because you made the solutions. You would measure out moles, dissolve it in volume, and find concentration. You would put your 0.1 molar solution in the spectrophotometer, and you would get an absorbance, and you'd have a coordinate on your graph. Right? Okay. So let me... These are percentages, absorbance percent. 10, 20, 30, 40. Okay? Question 1. If your concentration is 0, pure water, what's your absorbance? Absorbance is 0. Transmittance is 100. So at 0 concentration, you have 0 absorbance. Okay? 0.1, let's say it's 15%. 0.2, 30, 0.3, 50, and you get a line, and you can make a line of best fit. This is with all of your known solutions. You knew the concentration, you found the absorbance. Then you can take your solution that you don't know the concentration of. You can put it in your spectrophotometer. It will spit out an absorbance. So let's say it spits out an absorbance of 20. You can go to your graph and go down, and you can say, oh, my concentration must be about 0.13 molar. 0.14, 0.15, whatever. Does this make sense? Use knowns to find an unknown. You could also, because you're really good mathematicians, find the equation of this line, y equals mx plus b. Y would be your absorbance. M is just the slope of that line. X would be your concentration that you're looking for. And your y-intercept is 0, right here. And you could solve. You could plug in, once you know your slope, you could plug in your slope and your absorbance and solve for concentration. Your slope is actually equal to your absorptivity times your path length. And the molar absorptivity is just a constant for your solution. The path length has to do with your spectrophotometer and how far the light is from your sample. Usually 1 centimeter or 0.01 meters, but don't worry about that. Questions? Yep.
So if you were using a spectrophometer, do you put it like a certain length
No, it's set up already in the spectrophotometer. You'll see tomorrow in the lab. But it's just, it's a setup, it's a set distance. Questions?